Welcome back to this final episode in our 6-part mini-series AI Unpacked. Let's talk about the future, not just tomorrow or next year, but the decades ahead. Where are we going with AI? What kind of world are we building? This is our final episode, and it's time to lift our gaze to the horizon. If you followed this series from the beginning, you now understand where AI came from, how it works, and what risks and opportunities it brings. Today, we go deeper into the future. We explore what artificial general intelligence is, and what will happen in the age of artificial superintelligence, and what lies beyond the silicon chips we're using today. Could the next revolution already be forming? Right now, we have narrow AI, models that are good at specific tasks like recognizing faces or summarizing documents. The next big milestone many experts talk about is artificial general intelligence. That would be an AI as versatile and as smart as a human, able to learn and understand any intellectual task. We're not there yet, however, some say we are closer than others. What we have today are powerful generative AIs like ChatGPT. They can produce essays, conversations, or images that seem creative, but they're still essentially pattern recognition machines. They don't truly understand or possess general common sense. So when we say AGI, we mean a hypothetical future AI with human-level general intelligence. But artificial superintelligence will go way beyond even that. An ASI would set its own goals, reprogram its own code, and keep learning at a pace we can barely imagine. It could solve climate change, it could cure cancer, it could control surveillance systems, destabilize economies, and rewrite the world's balance of power. Thinkers like Geoffrey Hinton, Nick Bostrom, and Eliza Yudowski warn that we're already hurtling towards this future without a clear plan to ensure these systems align with human values. Hinton, who left Google in 2023 to speak more openly, has called for urgent action, even regulation. Sam Altman has compared the potential risks of AI to pandemics or nuclear war. Elon Musk says it bluntly: AI is potentially more dangerous than nukes. And they may be right. The concern isn't just what an ASI would do. It's that we might not understand it. Imagine creating something so complex, so fluid, that we lose our ability to predict its behavior. That's the alignment problem. And unless we solve it, we're driving blind at light speed. But the conversation doesn't stop with fear. There are others like Yann LeCun who argue that human-level AI is far from imminent, and that with careful governance, development can proceed responsibly. That tension between optimism and caution is what defines the next phase of our AI story. We're not just facing a technical challenge, we're negotiating a moral frontier. Now, let's shift from machines to minds. Picture this. You think of a question, and the answer appears in your visual cortex. Or you compose an email with your thoughts alone. Welcome to the world of brain-computer interfaces, BCIs. Companies like Neuralink are building tiny devices that link our brains directly to digital systems. In the short term, they're designed to help patients with spinal injuries or to restore sight. But the long-term goal is much bolder. Merge human cognition with AI. This raises wild possibilities. You could back up your memory, learn new skills instantly, access cloud data as if it were part of your own mind. But let's not ignore the shadow. Who owns this interface? Can it be hacked? If someone else controls the software, do they also control your thoughts? And what happens to inequality? Do the rich become mentally augmented superhumans while others fall behind? We're not just talking about new tools here, we're talking about a new definition of being human. Neuroscientist and tech philosopher Anders Sandberg puts it like this: our brain is not a closed system. Once we connect it to machines, it becomes something new, something we haven't fully understood. There are also cultural implications. How do religions, philosophies, and ethical frameworks adapt to a world where mind and machine are interwoven? Could the concept of consciousness be redefined entirely? Some futurists speak of digital immortality, the idea that we might preserve ourselves in digital form long after our biological bodies fade. It sounds far-fetched, but so did AI-generated art, voice cloning, and real-time language translation just a decade ago. AI may change how we define value in a world where efficiency is automated. We may find that human contribution shift towards the uniquely emotional, spiritual, and interpersonal. Coaching, caregiving, mentoring, these could become the most prized jobs of all. The AI arms race isn't just about clever algorithms, it's about processing power. But here's the thing. Only relatively few companies have access to this level of hardware. It's expensive, it's scarce, and it's creating a power imbalance. As processing power or compute becomes more central to AI's progress, the companies that control it hold the keys to the future. In response, some governments and coalitions are starting to invest in sovereign compute strategies, attempting to secure national access to GPU power. The EU, for instance, has floated the idea of a compute cloud for shared access across member states. Because without access to hardware, AI development becomes an exclusive rather than an inclusive game. Let's keep it simple. Normal computers use bits, ones and zeros. Quantum computers use qubits, which can be 1, 0, or both at the same time. That means they can explore many possible outcomes simultaneously. Think of it like being able to read every book in a library at once. This could change everything from drug discovery to logistics, from climate modeling to cryptography, from material science to, yes, AI training. Google's Sycamore quantum processor already solved a problem in 200 seconds that would have taken the world's fastest supercomputer 10,000 years. But we're not there yet. Quantum machines are fragile. They require temperatures close to absolute zero or minus 273 degrees centigrade, where atomic motion nearly stops entirely, which is colder than deep space. And their calculations are often noisy or unstable. But when these machines become practical, we'll reach what some call Q-Day. Q-Day is the moment when quantum computers outperform classical ones in useful, widespread tasks. It's coming, maybe 5 years, maybe 20. But when it arrives, it will break today's encryption, exponentially accelerate AI, and unlock discoveries we can't yet predict. We stand at a crossroads. One road leads to extraordinary breakthroughs, to climate solutions, to medical revolutions, to a renaissance of human creativity. The other leads to deeper surveillance, rampant misinformation, algorithmic inequality. Both roads are being built right now. The real question is, who's drawing the map? AI is not an alien force, it's something we are building. It's based on our data. It reflects our patterns, our decisions, our assumptions. It can amplify our worst instincts or elevate our highest aspirations. That's why we must approach this with humility, imagination, and collective responsibility. Because the road ahead isn't just about AI, it's about us. Let's be brave, let's be wise, but most of all, let's be human. This brings me to the end of this 6-part mini-series giving you an overview of AI. I hope you enjoyed it and found it useful. I'll leave some information in the comments below about how you can learn more about AI, and if you want guidance in how AI can help you or your business, I'll leave my contact details too. Thanks for watching, and as Alan Turing said, we can only see a short distance ahead, but we can see plenty there that needs to be done.